All right, good morning, everybody joining us today. Welcome to our webinar on developing smarter apps with Einstein Platform Services. My name is Shashank. I'm a Senior Manager Developer Relations at Salesforce. And today we are joined by Prajakta Samant, who is a Solutions Architect at Eternal Solutions. Hi, Prajakta.
Hey, hi Shashank. Hello everyone.
Yeah, so Prajakta is going to share her knowledge on her experience with working with Einstein Platform Services and using Apex and stuff like that. So before we move on, let me take care of some housekeeping stuff. Forward-looking statements first. It basically states that we might make some forward-looking statements about features that are not yet generally available. So please make sure you make any buying decisions on your own research and not what we're going to talk about today. And also, we are all up for social. Please feel free to tweet us out at Salesforce Devs. Find us on Facebook and LinkedIn as Salesforce Developers. And you can also always find our amazing YouTube channel, Salesforce Developers, where you can find all our recorded content in one single place. Great resource for developers like you and me. And also note this webinar is being recorded. So don't worry about not being able to recap or something like that. And the recording and the slides will be posted on the same page that you use to register for this webinar. So we're all good there. The webinar will be up after we are done in a day or two. Be a little patient there. And we have a live Q&A round towards the end. So we will take your questions and see how many we can answer. We'll try to answer as many as possible. The way you ask questions is you will see a questions tab inside GoToWebinar. You can just feel free to put your question whenever you get it. You don't have to wait until the last round. You can just keep posting your questions as you get them during the presentation itself, right? So in case if you don't get to your question towards the end, you can always head to our developer forums to post more questions on the developer.salesforce.com/forum site. So with that, here's the agenda for today, and Prajakta is going to give us more details on what we're going to talk about today. So Prajakta, what do we have on board today?
All right, thank you Shashank for setting the stage. Hope you all are able to hear me very well. So let's see what we have on agenda today. Since we are talking about Einstein Platform Services, definitely we need to understand some basic fundamentals of machine learning, because the terminologies that we will use, the concepts that we will use are all revolving around machine learning and deep learning especially, right? So let's understand some fundamentals, some terminologies, so we get acquainted with what we are talking about here. Then let's quickly see what Einstein Platform Services comprise of. It has Einstein Vision and Einstein Language. So we'll see what capabilities each of them offer. And then last but not the least, our favorite part, demo, right? So we'll explore a small demo and see how we can use image classification, sentiment analysis, and the intent APIs in action, however, using the Apex wrappers that we have. And then also the important part, of course, for each developer, right, to understand the best practices and the rate limits around which we will have to work.
This sounds exciting. So let's get started. So you're talking about machine learning and artificial intelligence and stuff like that. So what do these things actually mean?
Well, I am sure all of us are well acquainted with, AI, because it is so prevalent out there. We experiences almost all the time. So whether it's as simple as a shopping website that gives you the recommendation for the next purchase, or it can be as complex as the advanced tests that identify the probability of whether a person will develop a diabetes or not. So it's just everywhere, and we cannot really be ignorant of it. So let's see what machine learning is. So AI is a very vast field. What we are wanting to know today is about machine learning and deep learning, because that's what Einstein Platform Services is based on. So what is machine learning? I'm going to try and simplify it because none of us, I believe, is a data scientist here. So we're going to try and keep it simple. What is machine learning? So it's a process by which, as the definition goes, so it's a process by which the computers will acquire or able to acquire the ability to learn and get skilled in making some predictions, and without being explicitly programmed. Okay, so and the deep learning is a subset of machine learning. So we are going further deeper, little complex. So it's a subset of machine learning that works based on the learnings from the data representations, and not just the algorithms, the machine learning algorithms. So all in all, I would say data is the king here to make the meaningful predictions, more accurate predictions. And we'll talk more about it as we proceed in this session today.
Okay, sounds good. So can you maybe break this down into terminology that we can actually understand as someone who's hearing this for the first time?
Yes, absolutely. I'll happy to do that. So I will, take a very basic example that I just mentioned about a shopping website so that we understand these terminologies better. So say there is a book shopping website and it's recommending the next purchase of book for you. And how is it able to do that, right? So what it is doing when it's giving a recommendation, it's making a prediction whether that there is a high chance you will buy a certain category of book. So what it is doing is making a logical prediction based on a model. Well, then the next question would be, what is a model, right? So model is nothing but a classification system or a categorization system that got trained. In this example, it got trained based on the past purchase that you have made on that website, right? So you might have bought multiple books earlier, and that's what it used, that data got used to create a classification system to identify what kind of books you like, right? So that's a model. And the process that created this model using that sample data set, which is nothing but the past purchase history records, is the training. So this process of creating the model using data set is called training. And as we said, data is the king. All the collection of examples that got fed into this model for during the training process is your data set. So all the past purchase history records is the data set. And they got categorized based on certain labels. So again, going back to this example, say you bought maybe 50 books, out of which 10 were romantic novels and maybe 40 were some science fiction ones. So it kind of categorized it into the labels, that is romantic novel and science fiction. So now it's able to make a prediction that since you bought almost 40 books out of 50 for this particular category, this particular label, there is a higher probability that you will again buy a similar category of book. And that's how it was able to make a prediction for you. So this is how your machine learning will work based on the data set and all the examples that you feed into to make intelligent predictions.
All right, so now we have the terminology out of our way. Can we talk about the process now?
Yep, I think this will make more sense now that we understand those basic terminologies. So like we see, all the example data, the sample data that we have is our training data, as we call it. When you feed it to the algorithms, you generate a model, and the process being called as training the model. So once your model is ready, you have the categorization, steady for making some intelligent predictions. And when will that happen? When you have a fresh input of data to that model, it will generate a prediction and give you in terms of probability, whether a particular category is a higher chance of happening, or other category has a lower chance of happening based on the probability.
Sounds very interesting. So now where does
Yeah.
Einstein Platform Services fit into all this?
All right. So this is nothing but the basis of all the APIs and all the functionality that Einstein Platform Services offers. Let's go into a little bit more detail so we know exactly what it allows us to do and enables us to do. So we have two broad categories here. One is vision and another is language. So inside vision, we have again two specific categories. One is image classification. Here I would like to take a very basic example. Say there is an image and there is a fruit image. All right. So how do I identify whether that fruit is an apple or an orange? Right. So this classification is what the image classification capability will allow you to do. Okay. Moving on to object detection. Now, say we have same image, there is 10 fruits in the image. So how do I distinctly identify that there are 10 fruits and not two? Okay, so I can train a model based on a lot of data set saying that, hey, this is an image and this is how you distinctly identify based on the pixels, distinctly identify each fruit, and that's what object detection can do for you. uh, Moving on to language. So language again has intent and sentiment. Let me talk about the sentiment first, because it's quite, I feel, very easy to relate to. So given a body of text, given a sentence, I can classify that into positive, negative, or neutral. A very simple use case I can think of is, any service industry where the customer would give a feedback and you will want to ensure that the sentiment of the customer in terms of that feedback. So when you provide this text, this feedback text to the sentiment APIs, it can identify whether that is a positive, negative, and neutral, and accordingly you can take some actions based on that, right? And last but not the least, the intent APIs. Using those APIs, what you can do is classify a sentence or a body of text again, to identify what exactly that means. So it may not match the exact text, but even if you have similar text coming in, you will be able to categorize it into certain categories and take actions accordingly. So that's vision and language of Einstein Platform Services for you. Does that help, Shashank? Do you think that
I think
background?
it really helps, but what helps even more is maybe some examples of each of these things.
Yeah, I think that might be. So let's take an example of image classification. A very very common use case that you will see everywhere, no matter whether it's Einstein Platform Services or any other machine learning platform you might use. So say for example, in this case, we want to predict what is a repair estimate for a car crash. Okay, so if I have a model built which is fed with lot of different images of car damage, then it can be used to predict the level of damage and thereby predict what is the repair estimate for this particular car damage or a car crash. So that's how you can use image classification. Moving on to object detection, I just tried to keep it little interesting here. I love cats. So say for example you want to build a small app which can give you notification to ensure that all the kittens in your house are safe. So you can have an object detection, you can use the object detection APIs and build a model to distinctly identify how many cats are there in the image and accordingly shoot you notification if one of them goes missing, right? So I'm making it sound very simple. Of course there will be a lot of data set involved and the process, but object detection APIs enable you to do that, so you don't really have to go into the background and figure out how the algorithms work and how that training will happen. You don't have to worry about it. All you have to worry about is the data set and invoking the right APIs. Okay, so let's move on to sentiment analysis. Again, a very relevant use case here could be any feedback that's happening over the social media for your brand, and try to analyze the sentiment towards your brand, whether it's positive or negative or neutral, and then you can take some actions based on that. And intent identification, I would say case routing, which is also what we will see in our demo today. So you can use intent identification APIs to have the case routing done correctly based on the subject of the case, for example. So that hopefully again gives a little more background before we move on to the next.
Yeah. Yeah. So I think cat owners are going to be very happy once maybe one of our developers picks it up as a hobby project and builds something that they can use. What do you think?
Yeah, absolutely.
Okay, so yes, now we know what these are, how they come together and stuff. So how do we build something like this as a Salesforce developer or someone who works with Apex a lot?
Absolutely. That's our core area of interest for us developers, right? That's why we all are here today. So
Yes.
Einstein Einstein Platform Services is a separate account that you have to sign up. It's free, based on whether you want to use it for more predictions or less predictions, but it gives about some predictions free at the moment. So you can definitely sign up and try it for yourself, build some use case. So sign up for the Einstein Platform Services account, and then of course the Apex wrappers are available. So these are not really officially provided by Salesforce, but they are there for use on GitHub as open source projects. So why not leverage it? That's what I did, because I could then build up something very quickly. I don't have to worry about all the code for authentication and calling out the APIs. So that's readily available for use. And let's of course we will walk through the code, but I just wanted to show that we have two distinct Apex wrappers, one for vision, which has specific methods defined, whether you want to predict based on an image which is stored on a URL, or you want to do it from your local data file. And then similarly for language, there is a method defined for sentiment analysis, and there is method defined for intent analysis. So these I find really helpful in building something up for just trying it out. And then accordingly, if it fits your use case, then you can build a full-fledged application out of it.
Great. And we are listening to a lot of things. I think it's demo time, right?
Absolutely. Let's see. So I'm going to quickly move on to the scenario here. Okay, so this is again what we saw in one of the slides where we were using the intent API for case routing. So what I'm going to showcase today is a typical customer service scenario where, so what are the three primary things that I as a customer rep or I as a customer service organization would be interested in? One is the incoming cases get routed to the right department, so that they don't end up getting assigned and reassigned, causing frustration of the of my customer, right? So that's what I would like to do. Second, once I have a case, how do I quickly resolve it and make my customer happy? So I don't want to be sending emails back and forth saying that, hey, what is it about, just because there is not information much available. Why can't I make some predictions based on utility that I may build to see what my customer is actually expecting? So if I can understand a lot without asking, I'm sure my customer will be happy with my service. And last but not the least, after I do my job, I would like to understand how happy or not so happy my customer is. So of course, check the sentiment. So that's what we are going to see today. So this is a car shop that deals into the accessories, new car sales, as well as repair. So when there is a case created, it got routed to the right department, and that was simply based on a subject, right? So how did we will take a look into details how did that happen, but I just wanted to give a background on what the scenario is. So that case got routed based on the subject here. Now let's see what all information we have on the case. We have the contact phone. Well, I don't want to really start calling my customer unless I see what all I have on the case. Well, I see an attachment. So why not just download this image and try to see what model of car my customer has, what accessories shall I recommend. So I have that image downloaded already. I'm going to just use my small utility built here, which is based on image classification, and I'm going to try and predict what that car image is, so that I don't have to email and ask that what car model do you have. So let's see if it can. Oh well, yes. So it can make a prediction for me and says that my customer has a Tesla Model S. So in this case, I will be able to recommend the right accessories for that particular model, right? So I actually saved myself time on sending an email asking, hey, what model of Tesla you have, as well as it makes me look a little smarter that, well, I'm using the information in the case and not simply, calling or emailing the customer with questions, right? So hopefully that will make my customer happy. And say because of that, so when I resolve this case, I recommended all the all the accessories relevant. Say my customer has given me a comment saying that service was, let me try to, so service was prompt, and just going to try writing few feedback item here. So again, I'm doing it in a very basic manner just for the sake of demo, but you can build a lot of automation out of this. Like you can even have your feedback captured and just generate a sentiment score out of it, right? You will not need to really build the VF page and a click button and all of that. So how does serve? So let's see, let's try one more. It did not really predict the sentiment well, so let's try writing something better. So here I'm using the community sentiment model, which is pre-built. I'm going to try with that. Yeah, so it was able to predict that it's a positive sentiment. So having seen this, let's see what actually was done in the background to make this possible. So first we will see how the case routing happened, and then we will take a look at how the image was classified for the right model. Okay, so those are the two models that I built, and the community sentiment is something that is already available for use. You can start making predictions using that model. It's already offered by Einstein Platform Services. So let's see. So first and foremost, when we get Einstein Platform Services account, we also get a perm file with it. Using that, you will be generating the tokens. So let me go to the token generating URL, and I'm going to use the same email ID with which I did a sign up for the account. I'm going to go to the file and pick that so that I can get the authentication token. This is basically what you will require to make the call outs to the API. Okay. All right. So let's get started with the first scenario where we are going to do creation of data set and then train it and then run some prediction and see how did my case routing really happen. Okay. So let me put it here. I might not actually train the model if if it doesn't go in the first shot based on the internet bandwidth, but I'm going to try it. Let's look at the request parameters. So it takes the data and the type. Here it is text and the intent. So these are the request parameters that you will want to set when you are invoking this API. And let's go and select the CSV file. So there it is. Okay, let's take a quick look first at what this CSV file contains. Okay, how is my model going to be able to identify what are the different labels that it has to segregate it into? So this is my data set. This is what is the sample data that will be used to create the model. So say, for example, these are the type of sentences that I want to classify into sales category. These are what I want to classify into accessories category. And these are what I want to classify into repair category. So when I keep saying category, those are my labels. Okay, those are the labels which will then be used for making predictions, right? So when you're making a prediction, it has to show against a label whether it is 50% repair or 20% probability of accessories, and whatever is the highest is the most appropriate one, right? So let's go back to our Postman and try to create the data set. Let's see if it goes through. Yeah, so I was able to make the call out and it's still showing as uploading. So Shashank, do you think we are able to follow along? Am I going too fast on this or we are going well?
I think you're going pretty good.
Okay. So let's see. So we have a dataset ID and we can see if we are able to train that.
So if I understand correctly, Prajakta, you're actually showing us the process that we were talking about in building these models.
Exactly, exactly. Because, so let me talk a little bit about this while it's getting uploaded. So this process, the key thing here is this process we need to do just once, and then you can continue to run predictions out of it unless your underlying data set changes, right? So this is like train once and then make predictions all along. Okay, so this is an important step because this is where your model will understand what kind of predictions are you expecting out of it. So this is just once you have to do, but it's a very important step to do. So let's see if our data set is ready for starting the training process. So I'm going to use the token. Every time we make a call out, of course, we need authentication.
Yes, that's very important.
Yeah. So let's see if this data set is, yeah, looks like it is. Yep. So looks like it is ready to get trained. It's uploaded. The data was uploaded, the CSV and all the records in there. So let's start training the data set. I'm going to use the same token here. Hopefully it's valid, and give the dataset ID, then hit send. So what this will do is using all the data that we first provided in the CSV. It's going to create a model, right? So there were, if you remember, there were, let's go back, not remember, let's go back. Okay, so there are three categories of sentences or the text or the intents that we're trying to define here. One is sales, one is accessories, and one is repair. So when my model is getting trained, it's segregating the data that we provided into these three labels. So it is able to identify what is the intent of the incoming text, right? So let's see if the model is trained. So when you start training the model, what you will get is the model ID, and we can check if the model is ready to run the predictions. So let's quickly check that. Let's use the authentication and let's check the status of the model. If it's ready, then we can run the same prediction by using the same text. Okay, it's not, it's still running. So let's give it a couple of minutes. So what we are going to do is the prediction that we ran here, because of which the case was routed to accessories department, we're just going to try and run it manually from the Postman tool. So I'm going to show how did this model get, what is the intent of my case? How was it able to predict that? So let's see one more time if it's ready. That way we can generate some. Okay.
So while that is
Maybe.
happening, Prajakta,
Yeah.
can you maybe let us know difference in process or difference in data sets between intent and vision? Because I see both of them are classification systems based on labels, but I also heard that there is different way in which you actually provide data to these kinds of
Correct.
two different ones.
Right, absolutely. So when you are doing the image classification, a slight difference is because there is images involved. Of course, you cannot have them in a CSV. We had text for the intent, so we kept it in a CSV and generated the model out of it using the labels. But when it comes to images, what we will have to do is you'll have to have separate folders, right, with all the sample images. So how my model was able to classify whether that is a Tesla Model S or X. So what I did is I had a lot of images, or not many, but some images of Model S, and similarly some images of Model X, right? And then I have to zip those into a zip file, and then I can send it for my API callout. So this is a slight difference, the way you will call out the image classification API versus your text or the intent API. And let's go back and quickly see if this is working, hopefully. And I think, Shashank, I'm just going to move on and try using a pre-trained model here. Because this is
Yes,
taking quite long.
taking time, we
Okay.
can use a model that is already trained. Yes.
Yeah. Okay. So this is a pre-trained model, and what we'll try to do is use the same subject as the text here and try and see if it gives us that as the right intent. So I'm going to go to the token. Let's just generate a fresh one and try to make a prediction here. So this is a pre-trained model that we are using. It was done using the same CSV file, so the results are going to look exactly the same. And this is a set of text or a text body that I'm trying to predict against, right? So when I give this as a text, it should be able to predict what is the intent here based on whatever initial data that we provided, the data set that we uploaded. Okay, so let's try this. At least since the model was pre-trained before the demo, it should, yeah. So what you see here is the response looks like this, JSON, and the model predicts that the text indicates that the case subject here is about new accessories, right? And that's how it got routed to the right queue. Okay. Uh, so this is how it's going to identify the correct intent in your case. Okay, let's move on to how we'll do the similar steps for image classification. So here again, I think the training the model is going to take time, so I'll just use a pre-trained model and explain the process. So as I said, I use the zip file and this API to upload my data set. When I do that, similarly, I'll get a data set ID that you see here, 1073876, and has a name as well. Then the next step will be again similar. You will train that data set using that data set ID as your request parameter. Yeah. And after that, again, when you send a fresh image file to it, that's what we did on the button click, correct? So when you do that, it's going to be able to predict what model it is based on the data set images that you provided. Okay, so now that we understood some bit of how this training and creation of data set and all the process happens in the background, which you will have to do just once and not do it again and again every time you have to make a prediction. So this is something that you can do either using a Postman, or you can build a utility in Salesforce using Lightning components, whichever works for you. But you don't have to really build an application for training process as such, because everything you can just do all these callouts using the Postman or any tool of your choice, and you will still be able to generate predictions from your application, right? All you
Hey,
need is
Prajakta,
your
so
Mhm.
yeah, this is great. Postman is a great tool. Even I love using it. I'm sure many people use it. But end of the day, we are people who write Apex, right?
Yeah.
So how can we do all this using Apex instead in a real world production situation?
Right. So Shashank, what I was trying to refer is training the model. You don't really have to, spend your time writing Apex, because that is something that you will do just once. So might as well, using any API tool rather than building something for that. And of course, all the logic, the business logic that you will, build has to be in Apex, because, for example, let's take a case here. So when a case got created, how did it got routed to the right queue, to the right department? Okay, so let's take a look at that. Uh, so here, what I've done is I just created a simple method reusing the code from these wrappers that are provided. And it takes the case subject and the case ID. Okay, and here I'm trying to define the model, the endpoint. So all of this, if you see, it is basically what we used here as well. Right, let's go here. So this is the same, right? The endpoint against which you're going to make prediction. But for that, you need a model ID. You have that model ID, so you can go ahead and compose the form, compose the request, give your endpoint here, give your access token, right? The one that we keep generating here. Of course, we are not going to do that. So you can write a small method to generate that access token, right? Let me go quickly to that method as well. Okay, so this is how you can, get your access token each time you make the call out, right? So because without that, you cannot access the API. So you will have your access token in place, you have your endpoint in place, and you can generate the prediction, right? So it's going to send every time, it's going to send the subject text and try to predict what is the intent. Okay, so with the JSON that we get, it's going to give you the list of predictions, correct? And the model predicts that the particular subject is similar to what we want to do routing for the accessories. This is how it should get routed to the accessories, and it gives a probability. So in the background, if you see, let's go back to the JSON, you understand a little better. So this is going to give you a probability, right? It's a numeric prediction, it contains a probability. And generally what will happen is if you run a prediction, uh, it will always return the results in the descending order. So if you see, the topmost probability here is accessories. Similarly, here, that's why I'm referring only to the first value in the list. I'm not really bothered about all these, because new accessories, the intent is not really a repair or a sales. And that's why that is not my highest probability. So all I'm concerned about the highest probability in my list, and then accordingly I can do the routing of my case, right? So I think with since it's all about working with the REST APIs, uh, the Apex part of it is not as complex in my opinion. It's more about understanding, training the model, and how do you give the right data set so that it generates the correct prediction. It's all about that. It's understanding the concepts a little bit. We all are very proficient with the Apex development side of things, I'm sure. But here we'll have to do a little bit learning about understanding the concepts about data set, and what is the set of examples that you should provide. And we'll talk a little bit more about that as we proceed.
Wow, that was a lot of information, Prajakta, with the demo. And obviously, the next most important thing to talk about is best practices, right? So, do we have anything for us?
Yes, yes, absolutely. And that's what I want to kind of, focus in this session, because as I said, the Apex development part is really, I don't see any learning curve there, because it's REST API. We all know how to make those callouts, and it's all about writing trigger and things like that. So, but what is the key here, so that, what is the key here so that you generate the correct predictions? The key, I would say, is your data set, right? So if you are training a model with really good quantity of examples in your data set, then it's going to give you the model which is able to predict with more accuracy, right? So typically it is recommended at least 1,000 distinct examples. And last but not the least, the variety. So if you have distinct variety, the model is going to be able to learn in different scenarios what prediction it should generate, right? So variety of example in your data set is again something very important to keep in mind. And another prerequisite, or the best practice, I wouldn't say only a best practice, but it's kind of a prereq, that if there is change in the data set, so if the underlying examples are changing, and if you do not retrain the model is going to make predictions based on whatever earlier examples were given, right? So now if the underlying scenarios are changing, the examples are changing, you will have to retrain the model. Again, you will have to do it only once, but you have to do that so that it makes the accurate predictions. So retraining the model is another thing that we should keep in mind if there is change in the data set, change in the examples. And as I mentioned earlier, when we are signing up for the Einstein Platform Services account, there is a free tier which I used for building the sample use case for trying out. So there is a free tier and a paid tier. For free, there are about 2000 predictions per calendar month, and for paid, it will again, vary basis of the tier and what amount of predictions you want to make typically. So yeah, this does this help, Shashank? Does this answer your question?
Very helpful, and I'm sure there are some more questions as well, but we'll do it towards the Q&A at the end. But again, what are the key takeaways for us today?
Well, key takeaway is a very good, I would say, good capability that Einstein Platform Services has given to us Salesforce developers. Because otherwise, anytime we talk about machine learning and AI, we always had to kind of, say that, hey, we are just Salesforce developers. How do we use it in our application? But Einstein Platform Services has resolved that for us. So you can embed the image recognition or language processing into any Salesforce application. So it's really taken the hard part away and made it easier for us to build smarter applications. And it also has some pre-built image and language models. So for example, when I did the sentiment analysis in the demo, I was using the community sentiment model, which is pre-built. I did not have to use any data set or any examples to build a model. So it was ready for use, is ready for making predictions. And similarly, there are some pre-built image models as well. So there is a general image classifier. There is a food image classifier, which you can try out. It's really fun. So give it an example or give it a image of a pizza or a burger, and it can easily identify whether it's a pizza or a burger. So it's really fun thing to try out, before actually building a business use case, so that you feel confident that you can build stuff. Um, and last but not the least, this is what provoked me to really try it on my own without having really a lot of data science background. Of course, I did take up a course on machine learning, which helped me understand these basics very well. But then, I was able to try it out because it is all REST API based. So simply calling out the APIs, I was able to train the deep learning models. Otherwise, they are really inaccessible, I would say, for us Salesforce developers. And most important part, you can add feedback to the data set. So like we said, whenever there is a change in the underlying data set, you will want to retrain the model, or if maybe your model is not making the right predictions, then you want a way to retrain and tell the model that, hey, this is not the right prediction, this is the way it should be predicted. So you can add feedback to your data set using your data set. So the APIs, the 51 APIs that currently are available, I think they're very expansive in terms of, they're covering everything that you will typically need in this entire process of creating and training the model and retraining it.
Okay, now I'm excited to try it on my own. How do I do that now?
Well, our favorite, right? So who doesn't know Trailhead, correct? Trailhead
Everybody
should
does.
be, yes, absolutely. It should be your next step. I mean, I think with the Trailhead, there is like literally nothing that you cannot learn, right? So try out these Trailheads. You can quickly build things using this Trailhead and try it for yourself and feel confident that, then you will want to kind of take it to your client and say, hey, this is a use case we can build for you, right? So use Trailhead. There is a good explanation given there as to why we are doing each step, because if you understand the basic ones, I think it creates like a good foundation to build whatever complex use cases. Because of course, when we are going to build a real use case, it is not going to be as simple as like case routing and clicking a button here and there. So you will want to get your basics correct, and you can definitely do that using Trailhead.
Okay, a lot of information, great stuff. And do you know what time is it?
Oh
It's
yes,
Q&A
we have to
time.
take some questions. Yes, of
Yeah,
course.
so we have promised questions and answers for our attendees today. So we got some pretty interesting questions today. Let's see if we can take some of them. Are you ready?
Yes, let's do it.
Okay, let's start with simple questions first to get you into the mood. What do you say?
Sure.
Okay, is this accessible through Java or Java APIs?
Right. So there are Java wrappers as well. It's not limited to Apex, so you can definitely use it through Java.
Okay, that answers that. Okay, so what should be the sample size generally for these things? Is there like a limit on data set or maybe the size of that cat images or something like that?
Not really a limit, I would say, but if you try to upload a lot of data in one go, it's going to take really long to, train the model. So you might want to just have few hundreds of images at one go and then train and retrain that model. So that might be faster for you.
Okay, so there was one more question around the training process. Do we have Apex wrappers for the training process as well? Maybe open source ones or something?
I think there might be. I haven't tried them, but I saw them somewhere on the trailhead. So I think there are Apex wrappers for training as well. But in my opinion, it's really easy if you do it with Postman because the UI is very simple. So you don't really have to worry about Apex wrappers for training the model. Why would you want to put unnecessary code in your org?
Yeah, absolutely. That makes sense. And so there is one question around how customizable are these APIs?
Well, what do you mean customizing? These APIs are available only for making callouts. You can't really modify the way these APIs work, and you will not want to unless you're a data scientist, right? Because they have been built on certain pretty intense logic, so they are not really available for edit.
So in case I want to have a customized version of this, all I have to do is just learn data science for 4 or 5 years, right?
Better, yeah.
Okay. So if I want to save 4 or 5 years of my time, I can just use these APIs. Is that correct?
Yeah, exactly. Faster, smarter, right? That's the whole purpose.
Okay. So there is one question around. Maybe we can clarify some more on this. So we used intent APIs for routing cases. So, and
Mhm.
what is the advantage of using something like this instead of something like case assignment rules and stuff like that?
Yeah. So case assignment rules, I was expecting this question and good that it came up because that was exactly what I thought first when I was going to try this out. Like, why wouldn't I simply use assignment rules? Why bother about
Yeah.
building a model and making predictions and all that jazz? If we see the assignment rules will typically work on, exact text match, right? And this process is exactly opposite of that, I would say. So it doesn't rely on exact text match. So in the CSV file that I used, nowhere did I write a sentence saying that if it is new accessories, then it should get routed to accessories. No, based on lot of text that it found in that Excel, it was intelligently able to predict that if this kind of a text comes in, it matches this. I did not have to explicitly program it to do that. And that's the whole purpose of using machine learning. You don't have to explicitly program each and everything. It's not simply like if else kind of, text matching. So hopefully that answers the question.
Yeah, I'm sure it does. And so I think we did talk a bit about it, but we can probably still rephrase. So what is the difference between image classification and object detection?
Sure. So, object detection, it gives you capability of, so given an image, you want to distinctly identify multiple objects, if I say it. So, if you want to distinctly identify multiple objects inside one image, the object detection APIs gives you capability of doing that. Okay. Whereas image classification, that entire image is classified into something. It's not going to distinctly identify what different objects are there inside that image. But with object detection, you can go to the pixel level and kind of set those boundaries in the image and say, hey, this is apple, this is orange. So distinctly identify multiple objects given an image. I can take an example if that helps. Shashank, do you think? Should I just explain with an example here?
Do you want to show an example?
Not show an example, I can talk about one. So say for example, there is
Sure.
an image. Yeah, so say there is an example of image of a refrigerator, okay? And a refrigerator in a store which has 10 bottles of any soft drink, okay? Typical inventory management kind of a scenario. So your object detection is going to able to identify, once it's trained, it's going to be able to identify that there are 10 bottles in your refrigerator and your inventory is quite up to the mark. Now, say if tomorrow I click the image of the same refrigerator and one bottle is less, it will be able to identify that, hey, there are only 9, right? And then thereby kind of send a notification saying that, hey, the inventory is less by 1. So that's the level of object detection APIs that gives you.
Makes sense. Makes a lot of sense. So there is one more. Even I'm not sure what's the answer for this, but let's see if you probably know. You can tell us if you don't know. But using object detection, can we actually
Mhm.
recognize signatures?
I would say yes. But why would you use object detection for signatures? I mean, I wish I could ask that question,
Usually,
but
usually there'll be use cases like document processing and stuff like that. But one thing to note
correct.
for people who ask me this question is uh, vision is not exactly for document processing. Document
Right.
processing is a different subject all on itself. And this is, I mean, the vision API is the classification and detection is not exactly for that specific use case.
Correct, correct. Unless that image is really extremely good quality, it's not going to work.
Yeah. Okay, so there is an interesting doubt here. So are we
Okay.
actually using IBM Watson in the background or something for this?
No, 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 no. So that's what. So there are different machine learning platforms that you can use. So there is IBM Watson, there is Einstein Platform Services, and then Microsoft has their own. You can try out. So these are different types of platforms, but Einstein Platform Services has pretty expansive APIs. So I didn't feel the use of the need for IBM Watson here because platform services is giving me everything that I need for this use case.
Okay, and we have readily available Apex wrappers if you want to use Einstein Platform Services.
Right. Yeah.
That is there. Okay, so one more question around, is there a limit on the text that you can send or something like that for the sentiment and intent APIs?
The answer stays the same whether it's image or text. There is not really a limit because based on what paid tier you purchase, your limits will be defined on amount of data that you can use for training the models or creating the data set. But it's advisable to not really use extremely large amount of data in one API callout. So either you might have timeout or it might take really long time for processing. So rather, break it down into smaller chunks and multiple CSV upload can do that for you.
Okay, so that's pretty much most of the questions we could manage in time. In the interest of time, I would request any of the questions that you have unanswered or something, feel free to reach out to the developer forums and post your questions there. We'd be happy to have a look and answer. And apart from that, if you're wondering where can you find resources and stuff, you have Trailhead. Obviously, you can just do Einstein Platform Services in Trailhead. There are some really good Trailhead content there. And there is also the API documentation for Einstein Platform Services. Just go to einstein.ai and check the API documentation. The site is again einstein.ai. Easy to understand, I hope. Like very obvious name and URL. So einstein.ai is where you get all this stuff. And thank you so much, everybody, for joining us today. Thank you so much, Prajakta, for sharing your knowledge with our developer community today. Feel free
Thank
to
you,
reach out
Shashank.
to us on Salesforce Devs. Feel free to join our Trailblazer community group for Asia Pacific and India time zone developer webinars, bit.ly/webinar in APAC. With that, Prajakta, do you have any closing notes?
No, I think this is really very easy because of the Apex wrappers to try out. So I would recommend definitely try this out. Probably, over the weekend. It's a good project to try out over a couple of hours. And do reach out to me if you have any questions. I'm active on Twitter. So do reach out to me, and always post on the developer forums as well. I try to be active there as well. So, and thank you, Shashank, for giving me this opportunity. It was really good that I could share what I learned.
It was our pleasure as well. And thank you so much for doing this. And thank you so much, everybody, for joining us today. And see you later in the next webinar. Bye bye.
Bye bye.